As your safety director, I'm here to emphasize the importance of personal fall arrest systems, or PFAS, in our industry. As Glaziers, we work at heights, and it's crucial that we understand how PFAS can help prevent injuries and fatalities. A full body harness is a critical component of any PFAS. It must meet ANSI Z359.11 standards for full body harnesses and be properly sized and fitted to the worker, with adjustable shoulder, leg, and chest straps. Before each use, the harness should be inspected for damage or defects. A back D-ring is essential for attaching the connecting device. Two common types of connecting devices are lanyards and self-retracting lifelines, often called SRLs. Lanyards must be made of synthetic rope, webbing, or cable. They should have a shock-absorbing design to limit fall arrest forces to 1,800 pounds or less. The length should be kept as short as possible, typically 6 feet or less, to minimize free-fall distance. Lanyards must be compatible with the harness D-ring and anchorage connector. Self-retracting lifelines, or SRLs, automatically lock to arrest a fall and retract the lifeline when not in use. They limit free-fall distance to 2 feet or less and must be rated for the intended use, with a minimum braking strength of 5,000 pounds. SRLs should be mounted overhead to reduce swing-fall hazards. Anchorage points are critical in any PFAS system. They must be able to support a minimum of 5,000 pounds per worker attached, and can be structural steel, concrete, or other solid, permanent fixtures. Anchorage connectors like carabiners and D-rings must be compatible with the connecting device. Anchorage points should be located directly overhead to minimize swing-fall hazards. The required clearance distance below the worker depends on several factors: the type of connecting device used, whether it's a lanyard or a self-retracting lifeline, the potential free-fall distance, the deceleration distance of the fall protection system. Typical clearance distances range from 17 to 40 feet, depending on the specific equipment used. Employers must calculate the required clearance for each work area to ensure workers will not contact a lower level in the event of a fall. To ensure the effective use of personal fall arrest system equipment, employers must provide comprehensive training on the proper selection, inspection, and use of PFAS equipment. PFAS equipment must be regularly inspected and maintained according to the manufacturer's instructions. Damaged or defective components must be immediately removed from service. In conclusion, a well-designed and implemented personal fall arrest system is crucial for preventing injuries and fatalities in our industry. By understanding the importance of full-body harnesses, connecting devices, anchorage points, and clearance distances, we can ensure that our workers are protected while working at heights. Remember to always prioritize safety and follow established protocols to minimize risk. Let's talk about test instrumentation. When it comes to testing equipment used for fall protection, it's essential to have accurate and reliable instruments to measure its performance. ANSI ASSP Z359.16-2016 provides guidelines for the development and testing of instrumentation used in fall protection products. Another important aspect is a quick release mechanism. This feature allows workers to quickly release themselves from a fall arrest system in case of an emergency. ANSI ASSP Z359.17-2018 outlines the requirements for quick release devices, ensuring that they are reliable and easy to use. Finally, let's talk about static tensile test equipment. Static tensile testing is used to evaluate the strength and durability of equipment used for fall protection. ANSI ASSP Z359.18-2017 provides guidelines for the development and testing of anchorage connectors, which are critical components of fall protection systems. In addition to these standards, we also have test specimens that play a crucial role in ensuring the safety of workers. Test specimens allow manufacturers to simulate real-world scenarios and test their products under various conditions. Now I'd like to highlight some key points from each standard. The code listed below requires that instrumentation used for fall protection testing meet certain performance criteria, including accuracy, reliability, and stability. The code listed below outlines the requirements for quick-release devices, including their design, testing, and marking. The code listed below provides guidelines for the development and testing of anchorage connectors, which are critical components of fall protection systems. It's essential to note that these standards apply to specific types of equipment and situations. For example, the code listed below only applies to instrumentation used in travel restraint, fall arrest, rescue, work position, rope access, and suspended component/tieback line systems. In conclusion, these three standards are crucial for ensuring the safety of workers in occupations requiring personal protection from falls from heights. By understanding the requirements outlined in ANSI ASSP Z 359.16-2016, Z 359.17-2018, and Z 359.18-2017, we can ensure that equipment used for fall protection is reliable, accurate, and easy to use.